There is as much ground on Mars as there is dry land on Earth. Mars is small. The radius is about 3,500 kilometers, roughly half of ours, and the surface area works out at about a quarter of the Earth's. But the Earth is mostly ocean. Only about 3/10 of our surface is dry land, and when you compare the dry parts, the two numbers come out almost the same. About 145 million square kilometers each, near enough that the difference depends on where you decide a coastline is. That is worth sitting with for a moment. Every desert, every mountain range, every forest and city and field on this planet, laid flat, would cover Mars with very little left over. The gravity there is about 38% of ours. A person who weighs 80 kilograms here would weigh 30. That lower gravity is part of why the landscape got so large. Mountains and canyons can stand taller before their own weight brings them down. The figures come from radar and laser altimetry from orbit. One instrument in the late 1990s fired a laser at the surface 600 million times and built a map of the whole planet, accurate to a few meters in height. The air left when the magnetism stopped. Mars has no global magnetic field now. It had one once, and the evidence is written into the oldest rocks in the southern highlands, which are magnetized in broad stripes, the way rock is when it cools in a field. A magnetic field is made by molten metal circulating in a core. Mars is about half the diameter of Earth, so it holds heat far less well, and its core stopped circulating early. Best estimates put the end of the Martian dynamo at around 4 billion years ago, not long after the planet formed. Without the field, the solar wind reaches the top of the atmosphere directly. It strips gas away, ion by ion, and the lighter the gas, the easier it goes. That process is not a theory. A spacecraft has been in orbit since 2014, measuring exactly this, watching escaping ions leave the planet, and watching the rate rise sharply during solar storms. The measured loss rate, run backwards over billions of years, roughly accounts for the missing air, so the water did not evaporate away for no reason. The planet lost its shield first, then its air, and then the pressure needed to keep water on its surface. Nobody agrees about the methane. Every list like this should end honestly, so here's the thing about Mars that is not settled. Methane is a simple gas, and on Mars it should not last. Sunlight breaks it apart within a few hundred years, which is nothing. So any methane in that air was put there recently, geologically speaking, by something. A rover on the surface has been measuring it since 2012. It finds a small background amount, well under 1 part per billion, that rises and falls with the seasons, and occasional spikes 10 times higher that come and go within days. An orbiter built specifically to hunt for trace gases, with instruments far more sensitive, has looked for the same methane from above and found nothing at all, below its detection limit, over years of observation. Both instruments are good. Both teams are careful. The proposed explanations include gas seeping from the ground and being destroyed near the surface before it can rise, and something about the measurement itself that is not yet understood. Methane can be made by rock and water reacting, with no biology involved at all, and that is the leading explanation if it is real. But the honest position today is that we do not know whether there is methane on Mars.